Hello students, we're going to take a look at the note sheet for D4, and you can find that on Canvas on Tuesday of the week of 4/18. And the topic is amplitude and period of sine and cosine. So I'm going to break this worksheet into different pieces and we'll work through it in different videos. So the first thing to fill in is the formula for amplitude, and I'm not going to take the time on the video to read all of this. But just to note that if you have a function like the first one, y equals a times the sine of x, or y equals a times the cosine of x, that we learned before that a value is going to have an effect of a vertical stretch. And remember, it could be actually a stretch away from the x-axis if a is greater than 0, or it could be a stretch, or you might think of it as a compression toward the x-axis if a is something less than 0. And so if we take something like the sine graph that we've been practicing, or the cosine graph, and we stretch it away from the x-axis in different directions, then what we're changing is the amplitude. And so this value of a is going to affect the amplitude. And amplitude will always be positive, so it's always going to be given by the formula amplitude is the absolute value of a. If a happens to be a number that's less than 0, then what will happen is it will also flip the graph over the x-axis. So we're going to be using this a lot. The period of sine and the cosine graphs. The formula for this, well, first of all, I guess we'll note that when you have a graph that's of the form y equals sine b or y equals cosine b, that when we have this multiplier that's inside the function, that has a horizontal change on the graph. And remember that the horizontal changes usually work sort of backwards of what you expect. So if b is something greater than 1, then instead of expecting it to stretch out, like if we have sine of 2x, instead of stretching it out horizontally, it's going to compress it horizontally. And then likewise, if you had something like a 1/2 x in here, then instead of pushing it toward the y-axis, it's going to pull it away from the y-axis. Again, I'm going to let you read all of this, but the important thing to fill in is the formula, and the formula for the period is going to be 2 pi divided by the absolute value of b. So what we want to do now is, at the bottom of this sheet and then the top of the next page, is lay out what the sine and the cosine parent functions will look like. And then we're going to be using those graphs as we go through the various transformations that we'll do. So the first one that we'll take a look at is the sine parent function. So we're going to sketch one period of the sine function on the interval from 0 to 2 pi, and then we'll fill in some values that are down here. So as far as filling in one period of the sine function, let's make a little table of values of x and y. And for the x values, we're going to pick some key values on the unit circle. If you think about going around the unit circle starting at 0, we're going to come up here to pi over 2, around here to pi, down to 3 pi over 2, and back around to 2 pi. So we'll put in 0, pi over 2, pi, 3 pi over 2, and then 2 pi. And then we're going to write down the corresponding y values that go with that. So remember now, you're putting these values into the sine graph. So the first one is going to be y equals sine of 0. And the sine of 0, if you think about that on the unit circle, is going to be 0. And then continuing on around, and I'll let you verify this for yourself, the sine of pi over 2 will be 1, the sine of pi will be 0, sine of 3 pi over 2 will be -1, and then the sine of pi over 2, we're back to 0 again. So if we graph those points on the xy coordinate plane, so on the x-axis, we have the values 0 to 2 pi. So I'm going to put the 0 here and the 2 pi. It doesn't matter where you put it on this. I purposely didn't put this on graph paper so that you can kind of lay it out however makes sense to you. And then we have pi in the middle, and then pi over 2, and 3 pi over 2. And then on the y-axis we want the 1 and the -1. And then we'll just plot these points. So we have 0, 0, pi over 2, 1, pi 0, 3 pi over 2, -1, and then 2 pi 0. And we already have had enough experience with this, hopefully, that you know what this curve is going to look like. So this is a graph of one period of the sine function, and we're going to call it the parent function. And as we do the transformations, we're going to concentrate on these 5 points that I'm going to call the 5 key points. And anytime you stretch the graph or shift the graph, we're going to show what happens to those 5 points. And you'll see that as we go through the examples. So remember that even though we've graphed one period, the sine curve continues on forever in both directions. So if we write the domain is going to be all real numbers, or in interval notation you can put negative infinity to infinity. The range, remember, describes the y-coordinate, so it's just from bottom to top. And so the range is going to be from -1 to 1, including -1 and 1. So that's why we have the square brackets. The period, we already said, is 2 pi. The period of a function is what's the horizontal distance that it takes to go through one cycle. Once we get to here, it starts over again. So the period is 2 pi. The amplitude, remember the amplitude is the distance from this middle line. And we find the middle line by taking the average of the high and the low. So the high is 1, the low is -1. So the average of those is going to be 0. So y equals 0 is the principal axis. And then the distance from the principal axis up to the maximum and down to the minimum is 1. So amplitude is 1. We already said the equation of the principal axis is y equals 0. And the maximum function value is 1. And the minimum function value is -1. So I'll stop there, and we'll do another video where we'll do the cosine parent function.